This video covers Morehouse's homework for Tuesday, February 28th through Thursday, March 2nd. On Tuesday, we're working on reviewing the basics of the distributive property. In question 1, you're asked to use models to prove that 3 times a plus b is equivalent to 3a plus 3b. I'm not going to show you this exact example, but I want you to recall what we learned in class today. In class, we covered how a model that looks something like this, 2 groups of A plus 2 groups of B, which is 2A and 2B, is equivalent to a model that's drawn like this. 1 group of A and B and a second group of A and B. So A plus B and A plus B. In question 1, you're asked to recall this idea, but this time the expression is 3 groups of A plus B and 3A plus 3B. You can pause now to complete question 1. In question 2, you're asked to select all of the expressions that have the same value as 17 times 29 plus 64. Let's take this opportunity to do a basic review of the distributive property. In class, we've been learning that this form is called the factored form. Factored form is when we have a number outside the parentheses that we're multiplying by both terms inside the parentheses. Factored form is often written like this: 17 parentheses 29 plus 64. We don't actually need the multiplication symbol. When 17 hugs the parentheses, we can assume that we're multiplying. When we have 17 times 29 plus 64, I know that I can multiply 17 times 29, and I can add the product of 17 times 29 to 17 times 64. Again, I am multiplying the number on the outside times both terms on the inside of the parentheses. Then I can find these two products and add for my final answer. In this question, you're being asked to determine which of these options is equivalent to the original expression. The hint is that there are multiple correct answers, because again, there are multiple ways to write this out. Go ahead and pause this video to complete question 2. In question 3, you're being asked to simplify the expressions using 2 different methods. The first one has been done for you. You can see in this example that the first strategy is to distribute, then add, or then multiply and add. So, in the example, they multiplied 30 times 20, because 30 is the factor on the outside, times the term 20 on the inside, and 30 times 1. 30 times 20 is 600, and 30 times 1 is 30. They added these two numbers for a final answer of 630. The second strategy they would like you to use is parentheses first, where the first thing we do is add the term inside the parentheses. In this case, 20 plus 1 is 21. Then we simply multiply. 30 times 21 is 630. For each of the examples in question 3, I would like you to solve in both of these ways, using distribution and by completing the operation in parentheses first. Pause this video to complete question 3. Finally, in question 4, you're repeating the same steps as in question 2. If you need a reminder, you can always rewind the video to hear the explanation for question 2. Next up is Wednesday night's homework. On Wednesday night's homework, you're focused on moving from factored form to expanded form, or expanded form to factored form. Let's talk about factored to expanded first. When we're moving from factored form to expanded form, we're multiplying the factor outside of the parentheses times both terms inside of the parentheses. First, I multiply 5 times x. Let me zoom in. I have 5 times x. When I multiply 5 times x, I get 5x, which belongs as my first term that I'm adding. Then I need to multiply 5 times y, the second term I'm adding, which is simply 5y. Remember, I need to multiply by both terms inside the parentheses and leave them separate because I can't add x's and y's. Now, in contrast, when I move from expanded form to factored form, I want to think about what I need to do to be equivalent to my expanded form expression. When I multiply 6 times whatever I put inside the parentheses, I need to end up back at 6a. In this problem, I simply need an a, because 6 times a is 6a, and a b, because 6 times b is 6b. These are the steps that will follow for each of the questions in this table. However, I'm going to model one more question where you don't have the factor pulled out for you, such as 4x minus 20. In 4x minus 20, I know that I need to move to factored form that looks something like this. I have a subtraction symbol because I am subtracting 4x minus 20, not adding. In this case, I need to find the greatest common factor that I can use to live outside my parentheses. So I will create a table for the factors of 4 and 20. I know that 1 times 4 is 4, and 2 times 2 is 4. I'm also going to write out all the factors of 20. 1 times 20, 2 times 10, and 4 times 5. Notice that the greatest factor that appears on both lists is 4, and so 4 lives outside the parentheses. I know that to get back to 4x, I need to multiply 4 by x. Again, that's my first term in expanded form. To get back to 20, I'll need to multiply 4 times 5, because 4 times 5 is equal to 20. When you're stuck on moving from expanded form to factored form, remember, this is factored form here with the parentheses, this is expanded form here without. Always use the GCF. That will help you to make sure you're pulling the correct number outside of the parentheses. Your last night of homework is Thursday, and in Thursday, we simply have a review of fractions. First, problem 1 is a few opportunities to find a common denominator, then add. The easiest way to find a common denominator is to find the least common multiple of your two denominators. So, if I skip count by 5s and skip count by 3s, the first number that is a multiple of both 5 and 3 is 15. I know I'll need to change 3/5 into some number of 15ths and 1/3 into some number of 15ths. Once I've found both of these fractions, I will simply add. Don't forget the step of finding the common denominator in all problems in question 1. In question 2, you're being asked to do the same thing, except for your subtract. You will use those same steps to find the common denominator. Finally, in question 3, you have a word problem. I'm going to ask that you complete the word problem on your own by thinking carefully about what's being asked. I'll read it here. Miss Hayes has 1/2 a liter of juice. She distributes it equally to 6 students in her tutoring group. How many liters of juice does each student get? How many more liters of juice will Miss Hayes need if she wants to give each of the 24 students in her class the same amount of juice as found in part A? If you're stuck, I recommend drawing a picture of this 1/2 liter of juice and thinking about what's happening to it. That should help you figure out what operation is being used in this problem.